Hello everyone, welcome to Engineer Science YouTube channel, and this is our third lecture of resolution of vector series. In this lecture, we are going to drive the formula for calculating the magnitudes of rectangular components of the vector. But first of all, we will revise that what basically the horizontal component is and what basically the vertical component of a vector is. The horizontal component is the component of the vector which is lying parallel to the x component, or we can say perpendicular to the y component. The direction of x component of the vector is always 0 degree, whereas the y component is the component of the vector which is lying parallel to y component, or we can say perpendicular to x component. And we know that the direction of y component is always 0 degree, is always 90 degree from the horizontal. If you want to get the basic concept of resolution of vector and the rectangular component of the vector, then you can go to the description box and get the link of the two video lectures in which these two basic concepts are described in detail. So this is the brief introduction of brief revision of rectangular components of the vector. You can see the definition of these components here on this paper, and as well as the diagram of this component on this paper. So let's move towards the calculation of magnitude of the rectangular component. Now, in order to calculate the magnitudes of the rectangular components of the vectors, I considered this diagram. In this diagram, you can see a vector which is f making an angle theta from positive x-axis. Now, I am going to resolve this vector into its x and y component. I draw this perpendicular line to x-axis. This component is the y component of the vector, and we know that this component is the x component of the vector. Here you can see a right angle triangle. I'm going to name this triangle as OPQ. Now let's consider this triangle out of this diagram, and we are going to consider this triangle in scalar form because we are concerned with the magnitudes of x and y components. So we are going to consider this, we are going to extract this triangle from this figure in scalar form. So consider a triangle in scalar form. This is the right angle triangle. This is the angle theta. This is fx. This is fy. And this is f. Now, since we know that for a right angle triangle, sine theta is equals to perpendicular upon hypotenuse. Here we can see that the perpendicular is fy, whereas the hypotenuse is f, the triangle OPQ. The perpendicular value is fy, the magnitude of the perpendicular is fy, whereas the magnitude of hypotenuse is f. Since f is dividing on this side, when we shift it to the left hand side of the equation, it will multiply with the sine theta. So f multiplied by sine theta is equals to fy, or fy is equals to f sine theta. This is the formula for calculating the magnitude of y component of vector f, where in this formula fy is the magnitude of y component, f is the magnitude of vector that is resolved into y and x component. Now we are going to apply the relation of cos theta on this triangle, since we know that cos theta is equals to base upon hypotenuse. So cos theta is equals to, in this case, the magnitude of base is fx and the magnitude of hypotenuse is f. So the expression becomes cos theta is equals to fx upon f. F is multiplying on this side. When we shift, f is dividing on this side. when we shift the f on the right left hand side of the equation, it will multiply with cos theta. So f cos theta is equals to fx, or fx is equals to f cos theta. This is the formula for calculating the magnitude of x component of the vector, where in this formula fx is the magnitude of x component and f is the magnitude of vector which is resolved. I forgot to mention theta here. The theta is the angle which is made by the vector from positive x-axis. Remember, we consider in this derivation that the resultant that the vector which is required to resolve in fx and fy is making theta from positive x-axis. So theta is the angle that is measured from positive x-axis in anti-clockwise direction, means it is the standard angle. We can say that theta is the standard angle. So these two are the formulae for calculating the rectangular components of the vector. Thank you.